Hi everybody, this is Mr. Karlovsky with a quick demonstration about the hyperbola. So here is an example of a hyperbola. This one is opening left and right, or horizontally we might say. And here's an example of a hyperbola that opens up and down. So just like how a parabola can open up, down, left, or right, our ellipses can be horizontally or vertically aligned. Same thing can kind of be said about the hyperbola. But as far as drawing one of these, which we will ask you to do in a little bit, it actually all starts by asking you to draw a rectangle. And the dimensions of this rectangle are going to come from the equation that we give you. And maybe it'll be wider than it is tall. Maybe it'll be taller than it is wide. Also, it might be the same dimension in both directions. And so then you might not be able to use words like big and small. Maybe the two dimensions will be the same. All right, but here I'm going to draw a rectangle where I have the width. You can count as 1, 2, 3, and 1, 2, 3 up, down, or right and left. And the height is 2 up and 2 down. All right, and so then you go, all right, so first we're going to draw a rectangle. Then to draw a nice hyperbola, we're going to draw the diagonals through those rectangles like so. So this is actually, notice how everything's kind of dotted because these aren't really there. These are kind of, I guess the black lines are asymptotes and the red lines are kind of just imagining a structure to make those asymptotes. And so again, I'm not showing you what the equation is of this for this picture. Obviously, 3 and 2 are related. But what I want to show you is that from this exact same picture of this rectangle with those diagonal asymptotes, we can get either the horizontal hyperbola or the vertical hyperbola. So, and I'll even put both at the same time. So that's kind of an interesting thing that's different from parabola and ellipse is that the same structure could have either the horizontal or the vertical alignment. And you're going to see in the notes how we'll know which one to draw and analyze. Okay, so it's kind of a fun little picture as I now adjust the box. Really, all I'm doing right now is adjusting the box, and the graphs are going to change with it. And you can see that there's wide and narrow. And here I'm going to make it where the box is actually a square. Boom, not quite, there we go. Square, and so actually those two hyperbolas are congruent, just kind of rotations of one another. But if we don't make it a square, then you can see there's kind of a narrower hyperbola and a wider hyperbola, and it all depends on the size of that box. Okay, and then the last thing I'm going to mention is that, I'll make this a little smaller to manage, is that just like every other shape we have, that picture is related to some special points, which again we are going to call the foci. So let me show you the foci for the orange horizontal one. They are right there and right there. Now, this one's a little harder to see what's special about it, and we'll talk about that in our notes in a moment. But those are the foci for the orange hyperbola. And then for this exact same picture where there's a blue hyperbola, those are the foci for the blue. Now, if you look at this geometrically, you might say that the orange one is like farther inside the mouth of the orange hyperbola than the blue one is inside the mouth of the blue hyperbola. So you can see that like it's not an equidistant where those foci are. However, if you forget about the hyperbolas and just look at the points, you might notice that they appear to be at the exact same value, up, down, left, and right. It looks to be a little bit more than 3.5 for this example. So that's one thing that you can see is that the foci are going to be, there's only going to be one number that tells you where to get it, but it depends on where it is relative. So just like always, it's going to be, the foci are going to be inside the mouth of the curve. That's true for the ellipse. That's true for the parabola. And so I just wanted to show you this diagram. I thought, these are the kind of things that I think we would do if we were in class to show you these neat demonstrations on Desmos or otherwise. But I just thought this would be a neat demonstration before we then go to the notes and figure out how an equation and the values in the equation will determine which of these graphs and how they look. Okay, so just kind of animating there. These can be kind of fun to do as things get narrower, bigger, smaller, wider. Okay, so again, nice little intro. Now you're going to watch the notes video and hopefully understand the hyperbola as much as you can. All right, take care. Have a good day.